Title: The Double-Slit Enigma, A Journey into the Depths of Quantum Physics. Introduction: In the darkness of the cosmos, where subatomic particles dance and the rules of classical reality dissolve, a seemingly simple experiment has captivated physicists for centuries. The double-slit experiment, like a window into another realm, challenges our understanding of nature's behavior as both wave and particle. While appearing elementary in setup, this experiment forms the foundation of quantum mechanics and continues to inspire groundbreaking research at the frontiers of human knowledge. This article is a calm, precise, scientific, and inspiring journey through the interpretations, theories, and latest findings related to the double-slit experiment. We will explore fundamental concepts, examine the most profound questions, and invite you to reflect deeply on the nature of reality. Along the way, we will reach over 5,000 words, with the hope that they will illuminate your mind and ignite your curiosity. Chapter 1: The Double-Slit Experiment, A Tale of Waves and Particles. The double-slit experiment was first performed by Thomas Young in the early 19th century, aimed at demonstrating the wave nature of light. When light passes through two narrow slits, the emerging waves interfere, producing a pattern of bright and dark fringes on a screen behind the slits, precisely what is expected from wave interference. However, with the advent of modern technology and the discovery of subatomic particles, physicists found that the same experiment could be performed with electrons, protons, photons, and even large molecules like fullerenes. The wonder deepens when these particles are sent one at a time through the slits. Remarkably, even then an interference pattern builds up over time, suggesting that each particle interferes with itself. This illustrates the quintessential principle of quantum mechanics, superposition. Yet, if a measurement device is placed to detect which slit the particle passes through, the interference pattern disappears, replaced by two simple bands. This profound observation raises unsettling questions. Does observation alter reality? Is consciousness a fundamental component of the universe? Chapter 2: Diverse Interpretations of the Double-Slit Experiment. The mysterious nature of quantum particles has led to a multitude of interpretations of quantum mechanics. The double-slit experiment serves as a battleground for these views. The Copenhagen interpretation, formulated by Niels Bohr and Werner Heisenberg in the 1920s, this view posits that the wave function is a probabilistic description of a system. Only upon measurement does it collapse into a definite state. In this interpretation, the particle traverses both paths until observation forces a single reality. The many worlds interpretation, proposed by Hugh Everett III in the 1950s, this theory suggests that every quantum event splits the universe into multiple branches, with each possibility realized in a parallel world. In the double-slit experiment, the particle goes through both slits in separate universes, and no collapse occurs. Pilot wave theory. De Broglie-Bohm theory. David Bohm, building on de Broglie's ideas, introduced a pilot wave guiding each particle along a definite path. This theory restores determinism to quantum mechanics and aligns with the results of the double-slit experiment. Consistent histories, advanced by Robert Griffiths and others, this interpretation eliminates the need for wave function collapse by proposing that quantum events are described by sets of consistent, decoherence-free histories. Each history offers a valid narrative of the system's evolution. Relational quantum mechanics. Carlo Rovelli's view proposes that quantum states are relative to the observer. Reality is defined not absolutely but as a network of relations between systems. Thus, what's true for one observer might not be for another. Objective collapse theories. Models like GRW posit that wave function collapse is a physical, spontaneous process not reliant on observation. According to these theories, quantum systems naturally reduce to definite outcomes after some time. Quantum information perspective. This view emphasizes that the presence or absence of information, not observation per se, determines the interference pattern. If path information is available, even if unobserved, interference vanishes. Chapter 3: Recent Research and Experimental Advances. Temporal double-slit. Researchers at Imperial College London created slits in time by modulating optical properties of materials on femtosecond scales. Light could pass only during specific time intervals, producing a time domain interference pattern, analogous to the spatial version. Femtometer scale interference. In CERN's ALICE experiment, rhomizons produced in heavy ion collisions exhibited interference patterns, indicating wave-like behavior at subnuclear scales. These patterns were observed as a function of detection angle. Entangled photons. Experiments using entangled photon pair showed that even without direct measurement, the mere availability of path information destroys interference. This blurs the line between information and reality. Reverse double slit. A novel approach reversed the double slit setup by engineering light fields to recreate interference patterns without physical slits. This opens the door to ultra-precise imaging technologies. Single neutron interferometry. At Wien, experiments sent single neutrons through dual paths simultaneously. The degree of path presence was measured, directly visualizing quantum superposition at work. Quantum education platforms. Interactive tools now allow students and researchers to simulate and visualize quantum phenomena, including double-slit interference, decoherence, and entanglement, fostering intuitive understanding. Final chapter, a glimpse into the soul of reality. As our journey through this enigmatic experiment concludes, we come to realize that the double-slit experiment is not merely a scientific setup, it is a symbol of the cosmos's complexity, the mystery woven into the fabric of matter, and the blurred boundaries between consciousness and reality. Does the